consider the basics of statistical mechanics. What this statistical mechanics deals with? What is the main principle behind the statistical mechanics we will study today? Okay. So in that, we'll take the concept of phase space in the today's class. Okay, what do you mean by phase space? How to understand the phase space we will consider today. The basic principle behind the statistical mechanics I had given you in the previous class, it takes care of the macroscopic property of microscopic systems. Okay, if the system is consisting of large number of particles, we have to consider the property of each and every particle, and you have to take the time average to find out the property of the entire system. I'll come to that later. First, we will discuss the phase space concept. What is phase space? Okay, so in mechanics, the state of the dynamical system with f degrees of freedom can conveniently describe using f number of generalized coordinates. Okay, you know that if a system is having f degrees of freedom, so for each degree of freedom, you need one coordinate to describe the state of the system. What do you mean by state of the system? In case of Cartesian coordinate system, the position of the system, position of the particle is considered to be state of the system in Cartesian coordinate system. In thermodynamic state, okay, we have to take care of PV diagram, pressure volume diagram. Okay, so PV diagram gives you the thermodynamic state of the system. Okay, if the system is having f degrees of freedom, it can be described using f number of generalized coordinates. If it has f degrees of freedom, you need f number of coordinates to describe the state of the system. Okay, that point you can remember. Let us take the generalized coordinates as q1, q2, q3, so on up to qf. Together with, we will consider f number of corresponding momentum coordinates, and they are defined as p1, p2, p3, so on up to pf. Okay, so what we have to consider in phase space, we have to consider f number of position coordinates, f number of momentum coordinates. Okay, if the system is having f degrees of freedom, we have to consider f number of position coordinates and f number of momentum coordinates to describe the state of the system. Simple example I will take. Suppose a particle is moving in a plane. On a plane ಅಲ್ಲಿ move ಆಗ್ತದೆ ಅಂತ ಇಟ್ಕೊಳ್ರಿ. on a smooth surface a particle is moving. Simple case. So position coordinates you can define. They are x and y. Okay, x axis, y axis. Okay, it has 2 degrees of freedom in a plane. On the plane ಅಲ್ಲಿ move ಆಗ್ತದೆ, it has 2 degrees of freedom. It can move along x axis, it can move along z axis, since it is a moving in a plane. Okay, so 2 position coordinates are needed. They are called as x and y coordinates, and we have to consider 2 momentum coordinates, momentum along x axis, momentum along y axis. That is the meaning of corresponding momentum coordinate. Okay, so x axis sambandhapattange the position momentum coordinate px is used. Py is the momentum along y coordinate or y axis. If you represent the position coordinates x and y, momentum coordinates px and py, it can give you the dynamic state of the system. Okay, dynamic state of the system and represent ಮಾಡ್ಲಿಕ್ಕೆ ಏನು ಮಾಡ್ತೇವೆ, we have to use number of position coordinates and equal number of corresponding momentum coordinates. Okay, so therefore the dynamic state of the system, okay, remember it's a representation of dynamic state of the system that can be represented by a point in a 2f dimensional space called phase space. Okay, which is spanned by f position coordinates and f number of corresponding momentum coordinates. Okay, so dynamic state of the system can be represented in a a space called a phase space. How phase space is defined? It is a space spanned by f number of position coordinates and f number of momentum coordinates, where f is the degrees of freedom of the system. Okay, so this gives you a particular point on the space. Okay, and it is 2f dimensional space. The dimension is 2f dimension. Okay, f number of position coordinates and f number of momentum coordinates. Totally, you need 2f number of coordinates. Okay, if degrees of freedom is 2, for example, a particle moving in a plane, degrees of freedom is, okay, it is having 2 degrees of freedom. Okay. 2 degrees of freedom it has. How many number of coordinates you need to represent the dynamic state of the system? You need 2f number of coordinates. Okay, 2 into 2, 4 coordinates are needed. What are those 4 coordinates? X and y and px, py. 4 coordinates are needed, and such space or such coordinate system is called as phase space. Okay, how to define phase space? Phase space is a coordinate system which is spanned by f number of position coordinates and f number of corresponding momentum coordinates, where f is the degrees of freedom of the system. Okay, next we'll move. As an example, we'll take the state of the moving particle along x-axis. Simple case I will take. A particle which is moving along x-axis, okay, which has 1 degree of freedom. It can move along x-axis only. It has 1 degree of freedom. How many number of coordinates are needed? 2 coordinates are needed, because 1 degree of freedom, f equal to 1, 2f number of coordinates are needed. That can be represented by a point in a 2-dimensional space with position and momentum as its coordinates. Okay, along one axis you have to take the position, along other axis you have to take the momentum. That is called as phase space. It is a 2-dimensional space. Okay, in the general approach, the system constituted by n particles, each with 3 degrees of freedom. Another case you will take. There is a system constituted by n particles. N particles are there, each with 3 degrees of freedom. Each particle has 3 degrees of freedom. Then the phase space is represented by means of 6n dimension with 3n generalized coordinates and 3n momentum coordinates, because there are n number of particles. Each particle has n degree of freedom. Sorry, 3 degree of freedom. Therefore, the number of position coordinates needed are 3n in number. Okay, ಒಂದು ಪಾರ್ಟಿಕಲ್ಗೆ 3 ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ ಇದೆ. ಪ್ರತಿಯೊಂದು ಪಾರ್ಟಿಕಲ್ಗೆ ಏನಾಗ್ತದೆ, 3 coordinates are needed. For n number of particles, 3n number of coordinates are needed. 3n position coordinates and 3n number of momentum coordinates. Totally, we need 6n coordinates, and phase space will have 6n dimension, 6 into n dimensions, 6n dimensions. Okay, remember, if a system is consisting of n particles with each particle having 3 degrees of freedom, then phase space is represented by 6n dimensional space with 3n position coordinates and 3n momentum coordinates. Okay, I will show you an animation to represent this phase space. Okay, so just a minute. Okay, so let us take simple example of a spring coordinate, a spring oscillator. Okay, spring oscillator, when you move this mass, you mass just bitre ಏನಾಗ್ತದೆ. So if you move this mass, what will happen? This will oscillate like this. Okay, so it is oscillation of the spring along one axis, that is y axis or x axis. It is 1-dimensional motion, or it is having only 1 degree of freedom. It can move up and down, 1 degree of freedom. So this is how the spring moves. It goes up and moves down. ಕೆಳಗೆ ಬರ್ತದೆ ಮತ್ತೆ ಮೇಲೆ ಹೋಗ್ತದೆ. Let us assume that this spring oscillator is undamped. Okay, so this is normal coordinate system, Cartesian coordinate system, and it can move along only x-axis like this. Okay, then consider this particular phase space. Remember, it is having only 1 degree of freedom. 2 coordinates are enough, one position coordinate and one momentum coordinate. So just to observe, when spring moves up, ಮೇಲ್ಗಡೆ ಮೂವ್ ಆಯ್ತಂದ್ರೆ ಏನಾಗ್ತದೆ, the momentum initially increases, position increases. Okay, momentum ಏನಾಗ್ತದೆ ಸ್ಲೋ ಆಗಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ and becomes 0 here. Momentum ಏನಾಗ್ತದೆ 0 ಆಗ್ತದೆ when it goes to extreme position. Then while coming back, its momentum increases. Okay, momentum increases, position decreases, and here momentum increases rapidly and again it becomes 0 here. Illi matte momentum 0 ಆಗ್ತದೆ. Then momentum increases like this. Okay, so that can represented in phase space by means of this diagram. It is giving you as then this momentum axis. This one is a momentum axis. Okay, horizontal axis that is momentum axis. So when spring goes up, then this will show this particular diagram. When it comes down, so simultaneously observe, comes down, it traces a circle. Circular shape will be traced by this. Okay, so corresponding phase diagram or phase trajectory for spring oscillator is a circle. It is a circle. Okay, that is actually the coordinate system having one position coordinate, one momentum coordinate. What is the position coordinate? It is a x. What is the momentum coordinate? It is px, where px is momentum along x-axis. Okay, this is a spring oscillator which is undamped. Undamped means it will not stop. It continuously oscillates. Then you will get a perfect circle as a phase space trajectory. The spring and phase space will represent you will get a circle. So phase space is the coordinate system having position coordinate and momentum coordinate. Illi momentum matte position coordinate ಎರಡನ್ನು represent ಮಾಡ್ತದೆ. Let us take damped oscillator. Suppose ಈ ತರ spring moment ಆಗಿ ಸ್ಟಾಪ್ ಆಗ್ತದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. So it goes up, ಮುಂದೆ ಹೋಗ್ತದೆ, ಮತ್ತೆ ಕೆಳಗೆ ಬಂದು ಸ್ಲೋ ಆಗಿ ಸ್ಟಾಪ್ ಆಗ್ತದೆ. Suppose the spring oscillator is going to stop. Okay, stop ಆಗ್ತದೆ. Then how phase trajectory is observed? So remember, position coordinate increase ಆಯ್ತು, momentum decrease ಆಗ್ತದೆ, then finally the momentum becomes 0 and position becomes 0. It traces a helical shaped trajectory. ಈ ತರ helical shape ಬರ್ತದೆ. It shows a helical shaped trajectory. Okay, it's a damped spring oscillator which goes to stop after certain time. Time is also shown here. After 30 seconds it will stop. Okay, good. So this is the phase trajectory. Phase trajectory is helical shaped, and that is how you can represent a dynamic state of the system in a phase space. Phase space andre enu? It is a space or coordinate system consisting of position coordinates and momentum coordinates. Remember, this system, spring system, has only 1 degrees of freedom. That is the reason why it will show only 2-dimensional phase space. ಯಾಕಂದ್ರೆ 2 coordinates ಸಾಕು. f degrees of freedom ಇದ್ರೆ 2f number of degrees of freedom are enough. Okay, we'll come to that. Right. So 1 degree of freedom means 2 coordinates are needed. It is a 2-dimensional space. Okay, phase space is 2-dimensional space. If there are n particles having the particles with 1 degree of freedom each, only 1 degree of freedom is in the product, then what will happen? You need how many coordinates? 2n generalized 2n dimensional space. Okay, remember this particular point. Next, we'll move further. The state of the system. Okay. Okay. The state of the system is represented by a single representative point called phase point. Okay. One instant of time, at a particular instant of time, if you want to represent the state of the dynamic system, it is represented by means of a point called phase point. So phase point will have the coordinates, one from position coordinate, another from momentum coordinate. So a point in a phase space is called as phase point that will represent the state of the system at a given instant of time. Okay. With the lapse of time, so as time runs, some or all the coordinates take different values and it results in the change of phase point. Okay. System ಏನಾಗ್ತದೆ ಅದರ momentum ಮತ್ತೆ position change ಆಗ್ತಾ ಹೋಗ್ತದೆ as time runs. Okay. Time move ಆಗ್ತಾ ಹೋದಂಗೆ ಏನಾಗ್ತದೆ, the coordinates of the system will take different values. Its momentum changes, its position changes. Because of that, it goes to different phase point in a phase space. A point in a phase space is called as phase point. So different phase point can be observed for a system with the lapse of time. Okay, time ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಂಗೆ ಏನಾಗ್ತದೆ, ಅದರ phase point ಕೂಡ change ಆಗ್ತಾ ಹೋಗ್ತದೆ. Okay, phase point will change continuously. So it will move from one point to another point in the phase space. Phase point is represented by a position coordinate and a momentum coordinate. So the collection of phase points with the change in time traces a curve in phase space called a phase line or phase trajectory. So all the phase points, if you collect with respect to time, okay, it will trace a curve, and that curve is called as phase line or phase trajectory. Okay, phase line and okay. So each point on the phase trajectory represents one possible state of the system. Okay, I have shown you for a spring oscillator, the phase line is circle. It is a circle. Okay, circle ಬರ್ತದೆ ನಿಮಗೆ. It is a phase line for the spring oscillator. Okay, so circle is a collection of phase points. Each phase point represent one possible state of the system. ಅಂದ್ರೆ ಆ ಟ್ರೇಸ್ ಬಂತಂದ್ರೆ, ಆ ಫೇಸ್ ಟ್ರಜೆಕ್ಟರಿ ಬಂತಂದ್ರೆ ಅದರಲ್ಲಿರುವಂತ ಎಲ್ಲಾ ಪಾಯಿಂಟ್ಸ್ ಏನಿದೀರಾ, ದೇ ಆರ್ ರಿಪ್ರೆಸೆಂಟಿಂಗ್ ಒನ್ ಪಾಸಿಬಲ್ ಸ್ಟೇಟ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್. ಅಂದ್ರೆ ಆ ಮೊಮೆಂಟಮ್ ಮತ್ತೆ ಪೊಸಿಷನ್ ಏನಾಗ್ತದೆ, that can be observed for that particular system. Okay, so remember three definitions. Phase point andrenu, phase point is a single representative point in a phase space which represent the state of the system at a given instant of time. With the lapse of time, all the coordinates may take different values and it results in the change of phase point. The system will move from one point to the another point and the phase point for the system changes. Phase point change active. What is phase point? It is a representative point represented by means of position coordinate and momentum coordinate. These collection of phase points with a change in time traces a curve, and that curve is called as phase line or phase trajectory. Okay, each point on the phase trajectory represents one possible state of the system. Okay, so each point on the phase line ಇರುವಂತ ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟ್ ಏನು ಕೊಡ್ಸಲ್ಲ, that will give you one possible state of the system. Okay, so just I will show you another animation in order to understand the concept properly. just you observe, it is undamped oscillator. ಇಲ್ಲಿರೋದು ಒಂದು ಪಾರ್ಟಿಕಲ್ ಏನಾಗ್ತದೆ, it is moving along x-axis, it is oscillating like this horizontally, then that can be represented by a simple harmonic oscillator by means of this particular curve. This simple harmonic oscillator is done. So if this particle is moving horizontally in the phase space, so this particle is represented by means of a circle. ಈ ತರ ಒಂದು ಸರ್ಕಲ್ ಅಲ್ಲಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೇವೆ, where this is x coordinate, this is momentum coordinate. Vertical is momentum, horizontal is position. Position nodi, it is continuously changing from -1 to +1. Here also it is changing from -1 to +1. Where momentum is changing, momentum is decreasing, it reaches minimum, then it increases in the opposite direction. ಇದು ಈ ತರ ಇನ್ಕ್ರೀಸ್ ಆಗಿ ಮತ್ತೆ opposite direction ಅಲ್ಲಿ increase ಆಗ್ತದೆ. So that is showing the trajectory of a undamped particle oscillator like this. Okay, let us take damped oscillator. Damped oscillator ಅಂದ್ರೆ ಏನು? The particle finally comes to rest. ಇದು amplitude ಜಾಸ್ತಿ ಇರ್ತದೆ, it comes to 1 before. So now it shows 1 ಇಂದ -1 ಗೆ ಹೋಗ್ತದೆ, then slowly its amplitude decreases. ಈ ತರ ಕಡಿಮೆ ಆಗ್ತಾ ಬರ್ತದೆ. That is represented by means of this particular trajectory. ಈ ತರ ಕರ್ವ್ ನಿಮಗೆ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು in a damped oscillator. Okay, it damps. Then in the phase space, how it is represented? ನೋಡ್ರಿ, ಪೊಸಿಷನ್ ಏನಾಗ್ತದೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಬರ್ತದೆ, momentum slowly changes like this and it goes to a helical shaped curve like this. This is damped oscillator, and this is the phase space containing a position coordinate and a momentum coordinate. Okay, and that is how you can understand phase space. Remember, phase space is a coordinate system having position coordinate and momentum coordinate. Other coordinates ಏನಿರ್ತದೆ, position coordinate ಮತ್ತೆ momentum coordinate ಇರ್ತದೆ. Okay, that is how we can understand phase space. ಫೇಸ್ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಇರುವಂತ ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟ್ ಗೆ ಏನ್ ಹೇಳ್ತೇವೆ ನಾವು, ಫೇಸ್ ಪಾಯಿಂಟ್ ಅಂತ ಹೇಳ್ತೇವೆ, ಆರ್ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಕಾಲ್ ಇಟ್ ಆಸ್ ಫೇಸ್ ಸೆಲ್ ಅಂತಾನು ಹೇಳ್ಬೋದು. ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಕಾಲ್ ಇಟ್ ಆಸ್ ಫೇಸ್ ಸೆಲ್. ಓಕೆ, ಫೇಸ್ ಪಾಯಿಂಟ್ ಆರ್ ಫೇಸ್ ಸೆಲ್. The collection of these phase points is called as phase line. Okay, so each point on the phase line represents one possible state of the system. One possible state of the system ಅನ್ನು represent ಮಾಡ್ತದೆ. Okay, that is what phase space should be understood. Then come to the principle of statistical mechanics. Okay, the measurement of macroscopic variables such as pressure, temperature, volume, etc., they involves the measurement of time averages over appropriate portion of the phase line. Suppose you want to find out the pressure, temperature, volume of this system by using the phase line. You have to take time average of these properties over the phase line. Okay, ನೀವು ಒಂದು ಸಿಸ್ಟಮ್ ಅನ್ನು ಫೇಸ್ ಲೈನ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರಿ in phase space ಅಂತಂದ್ರೆ you can find out the properties of the system. What you have to do, you have to take the time average of the phase line. Suppose you want to find out the position of the system. Okay, you have to take the average position of the system because it is a dynamic system. It continuously moves, continuous ಆಗಿ ಮೂವ್ ಆಗ್ತಿರ್ತದೆ. What is the average position of the system? Spring oscillator ತಗೊಂಡ್ರೆ, so basically the mean position is the average position. Okay, average position of the system is mean position. What is the average momentum? What is the average momentum? Remember, momentum is conserved there. Okay, so average momentum is 0. So that is how you can take a time average of the phase line in order to find out the macroscopic variables. What do you mean by macroscopic variables? They are measured variables, measurable variables such as pressure, temperature, volume. They are thermodynamic coordinates. Similarly, you can find out the mechanical coordinates such as position, momentum, etc. So in statistical mechanics, what we'll do, the macroscopic behavior of the system is understood on the basis of statistical average of behavior of microscopic states of the system. Okay, I have introduced the phase point. Phase point andrenu, phase point is a state of the system. ಆ ಟೈಮ್ ಇನ್ಸ್ಟೆಂಟ್ ಅಲ್ಲಿ ಅದರ ಫೇಸ್ ಪಾಯಿಂಟ್ ಏನ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತದೆ, ದಟ್ ಈಸ್ ದ ಸ್ಟೇಟ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್ ಎಟ್ ದಟ್ ಟೈಮ್. You take the collection of such phase points, then you take the average or statistical average, okay, of a particular variable. ಅದೇನು ಕೊಡ್ತದೆ, it will give you the macroscopic behavior, the large property of the system. Suppose you want to find out the volume of the system. Volume ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ, suppose a balloon, okay, balloon ಇದೆ ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ, let us take balloon is continuously expanding and contracting. Suppose balloon is falling, ಮೇಲ್ಗಡೆಯಿಂದ ಬಿದ್ದು ನೆಲಕ್ಕೆ ಬೀಳುತ್ತೆ ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ, when it falls to the ground, its volume suddenly decreases once, decrease ಆಗ್ತದೆ, ಮತ್ತೆ expand ಆಗ್ತದೆ. So volume is continuously changing, volume of the balloon is changing. Then what you have to do, you draw a phase trajectory or phase line for that falling balloon. Okay, so position coordinate ಮತ್ತೆ momentum coordinate ತಗೊಂಡು ಏನು ಮಾಡ್ರಿ, ಒಂದು ಫೇಸ್ ಲೈನ್ ಡ್ರಾ ಮಾಡಿ. Then you find out the average of behavior of the microscopic states. ಪ್ರತಿಯೊಂದು ಫೇಸ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅದರ ವಾಲ್ಯೂಮ್ ಎಷ್ಟಿದೆ ಅಂತ ಅವರೇಜ್ ತಗೊಳ್ತಾ ಬರ್ರಿ. You take the average of the volume at each phase point. Then that average of the volume is going to be the total volume of the system or the average volume of the system. Okay, ಅಂದ್ರೆ ಪ್ರತಿಯೊಂದು ಫೇಸ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನೀವು ಅದರದ್ದು ಪ್ರಾಪರ್ಟಿ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ತಾ ಬರಬೇಕು. Then take the time average. Okay, you take the average over time. So this is the fundamental concept of statistical mechanics. Okay, what you have to do, you have to measure the property of the system at each and every phase point represented in the phase space. Then take the time average of that property over time, and that will give you the macroscopic behavior of the system. What do you mean by macroscopic behavior? Macroscopic behavior andrenu, a measurable behavior, volume of the system, temperature of the system, etc. Another example I will give you. Suppose you want to measure the temperature of the system. Temperature of the system ಅನ್ನು measure ಮಾಡಬೇಕಂತ ಇಟ್ಕೊಳ್ಳಿ. Then suppose you take the temperature of the spring only. Spring the temperature find out ಮಾಡಬೇಕು. So spring is continuously oscillating and you draw the phase trajectory for that spring system. You will get a circle. Circle ಬರುತ್ತೆ ನಿಮಗೆ. Okay, or some ellipse shape you will get. Okay, so at each point on the ellipse you measure the temperature. Okay, when spring is at extreme position, what is the temperature you measure at the other extreme position. Similarly, at each and every phase point you measure the temperature. Temperature may change or it may remain constant. Then you take the average of temperature over time. It's a collection of large data. Okay, ಬೇರೆ ಬೇರೆ ಫೇಸ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಮೆಜರ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. So it is a collection of very large data. Then take the average of that data and that will give you the temperature of the system, and that system is dynamic. Okay, temperature of that dynamical system can be measured by taking the statistical average. Okay, because it is an analysis of large data. Large data analyze ಮಾಡೋದಂಗೆ. That's why the statistics is involved here. That is the reason why this branch is called as statistical mechanics. Okay, so basically what is the main principle behind the statistical mechanics? Statistical mechanics is useful in understanding the macroscopic behavior of the system on the basis of statistical average of behavior of microscopic states of the system. Microscopic states ಅನ್ನು ಸ್ಟಡಿ ಮಾಡಿ macroscopic behavior ಅನ್ನ understand ಮಾಡ್ಕೊಳ್ಳಿ. Okay, very small states should be analyzed, and that is used for understanding the macroscopic behavior. Macroscopic means large, microscopic ಅಂದ್ರೆ very small. Micro means small, macro means large. Macroscopic behavior of the large system can be understood by taking the microscopic states of the system. Okay, suppose you want to measure the temperature of water in a container. Suppose water is kept in sunlight ಅಲ್ಲಿ ಇಟ್ಟಿರ್ತಾರೆ. Okay, the molecules of water are continuously moving. Let us take the temperature of this water now find out ಮಾಡಬೇಕು. Okay, temperature of the water na find out ಮಾಡಬೇಕು. What you have to do, you have to find out the phase trajectory of that water molecules. Water molecule na phase trajectory find out ಮಾಡಬೇಕು. Remember, whenever the water molecules get some heat from the sunlight, the water molecule definitely move randomly. ಬೇರೆ ಬೇರೆ ಕಡೆ ಮೂವ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. You have to represent the motion of the molecules in phase space, and at every phase point you measure the temperature of that molecule. Okay, ಪ್ರತಿಯೊಂದು molecule temperature measure ಮಾಡ್ತಾವೆ. It is not a easy task. So just to understand the statistical mechanics principle, I am explaining this. Then temperature of the every molecule at different phase point measure ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. Then take the average of the temperature of the molecules, that will give you temperature of the water in the container. Okay, ಅಂದ್ರೆ ನೀವು large number of data you have to take. You have to measure temperature of each and every molecule at a different time. Okay, ಬೇರೆ ಬೇರೆ ಟೈಮ್ ಅಲ್ಲಿ ಅದನ್ನ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. You will get a very huge number of data. Then take the average of that temperature. That will give you the total temperature of the system. Okay, ಇದು ಬಹಳ ಡಿಫಿಕಲ್ಟ್ ಅಂತ ಅನಿಸ್ತದೆ ನಿಮಗೆ, ಬಿಕಾಸ್ ಟೆಂಪರೇಚರ್ ಮೆಜರ್ ಮಾಡೋದು ಅಂತಂದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಥರ್ಮಾಮೀಟರ್ ಇಟ್ಟು ನೋಡ್ಬಿಡ್ಬೋದಲ್ಲ, ಅದ್ರಲ್ಲಿ ಏನಿದೆ ಅಂತ. ಬಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಮೈಕ್ರೋಸ್ಕೋಪಿಕ್ ಸ್ಟೇಟ್ಸ್, ಸ್ಟಾಟಿಸ್ಟಿಕಲ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಇಸ್ ಯೂಸ್ಡ್. ಓಕೆ, ಮೈಕ್ರೋಸ್ಕೋಪಿಕ್ ಸ್ಟೇಟ್ಸ್ ಅನ್ನ ಸ್ಟಡಿ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾಟಿಸ್ಟಿಕಲ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ರಿಮೆಂಬರ್, ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಮ್ಯಾಕ್ರೋಸ್ಕೋಪಿಕ್ ಬಿಹೇವಿಯರ್ we have to take the statistical average of behavior of microscopic states of the system. This statement you have to understand properly. ಇದು ಪಕ್ಕಾ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ಬೇಕು ನಿಮಗೆ. ಒಂದು ಲಾರ್ಜ್ ಪ್ರಾಪರ್ಟಿ ಮಾಡ್ಬೇಕಂದ್ರೆ you have to study the property of the smaller of the system. That is the meaning. ಪ್ರತಿಯೊಂದು ಸ್ಟೇಟ್ಸ್ ಅನ್ನು ನೀವು ಸ್ಟಡಿ ಮಾಡಿ ಅದರ ಅವರೇಜ್ ತಗೊಂಡ್ರೆ ಈ ಫಂಡಮೆಂಟಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಸ್ಟಾಟಿಸ್ಟಿಕಲ್ ಮೆಕ್ಯಾನಿಕ್ಸ್.